Hello, my name is Jose Aparicio, and welcome back to my YouTube channel. Today we're going to be going over Notes 1.4 in the AP Pre-Calculus curriculum, polynomial functions and rates of change. Well, you're probably wondering, what is this graph? Well, this is a polynomial graph. And let's start talking about it. You're probably wondering, what is a polynomial? Well, here's an example of a polynomial. It's basically a function that is raised to different powers. It's different, right? Because I'm pretty sure you're used to quadratic equations and linear equations where they either have one variable raised to the power. Well, this time there's two. Well, you're probably wondering, what is a leading term and what's a leading degree and what's a leading coefficient? To find the leading term, you first need to figure out the leading degree and the leading coefficient. So many people get this. Many people always seem to have this common misconception about polynomial functions, and they always think that the leading degree and the leading coefficient is the number that's in front of the whole equation. But coincidentally, in this case, it is. But normally, it isn't, or it does. Don't get used to it being in the front. It could also be in the back. It could also be out of order. So how do we know what's the leading degree and leading coefficient? Well, leading degree is whichever variable has the highest degree. So the leading degree in this case, it's 4 because it's the highest degree. Leading coefficient is, after finding the leading degree, it's basically the number in front of it. So the leading coefficient is just 5. And so the leading term is just literally negative 5x to the fourth. Pretty simple. Alright, yeah, as mentioned before, note that sometimes polynomial functions will not be written in standard form. You have to look at the variable's largest exponent to find the leading term. In this case, it was 4. Because 4 is greater than 3.
In example 2, it shows, as mentioned before, a polynomial function, but this time it's not in standard form. So, what is the leading term? I'm going to give you a second for you to try to figure it out based on the clues that I gave you in the first example. You think you got it? Well, if you chose negative 2x raised to the 6th, you're correct, because it does have the highest degree. Now, what are relative and absolute extremas? Let's zoom into this picture. A relative extrema is when the polynomial function switches from a maximum to a minimum, or from a minimum to a maximum. So, that is what a relative extrema is, and now what a it's also known as global extrema, but they most likely speak of it as absolute extrema. So the absolute extrema is the lowest or the highest point of the graph. The highest point of the graph. So in this case, the absolute minimum is right here. It's right here because it's the lowest point of the graph. And so right here, you can literally just write that the absolute min of negative 2 is when x is negative 6. Next, now we're trying to find the absolute max, and you're probably saying, oh, it's right here. Well, actually, it's not. That arrow indicates that it goes on forever and ever and infinity. So in this case, we have no absolute max. Now, relative min. So our relative min is basically our lowest parts of the graph besides the absolute min. So in this case, it would be here and here. Now we're trying to find our relative max. And so these are going to be the highest points of the graph that aren't the absolute. So in this case, it's going to be right here and here. Now that we're done with that, let's go to the next picture that I have. Alright, so let me switch this to the pen version. Alright, 2 zeros equal at least one extrema. Like this. Oh, that is such a bad drawing. Sorry about that. So if you have two zeros of a polynomial, a non-constant polynomial, then there must be at least one local extrema between the two zeros. So in this case, sorry, I don't think I mentioned it before, but local, when they mean local extrema, they also mean the relative extrema. So as we mentioned before, the relative extrema is when a graph turns when the graph is increasing and then it turns into decreasing. So as we can see here, it's decreasing, then it's increasing. So in this case, there is a relative minimum. Okay. Even degree equals an absolute extremum. So if the polynomial has an even degree, there is either an absolute maximum or an absolute minimum. A positive leading coefficient means that there's an absolute minimum. And when the leading coefficient is a negative, there is a maximum. You may know this because let's just say we have negative 3x squared and 3x squared. Sorry, that's totally on the opposite side. Let's say you have negative 3x squared and 3x squared. The graphs for this one would look like this. So you have a absolute minimum. And then for this one, it's like this. It's flipped over. So you have an absolute maximum. Pretty simple. Pretty self-explanatory.
So that concludes the notes, and this is a problem that I found on the internet that is pretty helpful. It's pretty self-explanatory, pretty easy. And I will be posting the answer in the comments of this video. So no waiting. So don't have to wait for the next video. The answer will be posted in the comments. Thank you once again for watching my video. And if you like videos like this, don't forget to like and subscribe and follow the TikTok. And yeah, have a wonderful day.